In this video, we discuss error analysis questions from JEST exam. So here we have a question from JEST 2021. Here it is said that assuming the errors to be Gaussian distribution, Gaussian errors add in quadrature. That means if we need standard deviation, SD will be equal to root of sigma 1 square plus sigma 2 square. That is, we take error in 1 and square it, then add with error in 2 squared and then take square root, then you will get standard deviation. So in our case it will be the error in first measurement is 1.12 squared plus error in second measurement is delta squared. So this is the standard deviation. Now we are told that the two measurements differ by 3 standard deviation. So 3 into standard deviation is equal to 3 into root of 1.12 square plus delta square. This is equal to the difference in measurements, the difference in two measurements. That means let's say measurement 1 is m1 and measurement 2 is m2. Then you take difference, and we are only concerned with the magnitude, so we take modulus. So m1 minus m2 modulus will be equal to 3 standard deviations, 3 into root of 1.12 square plus delta square. We are able to write like this. The standard deviation is written like this only because it is said that the errors are assumed to have Gaussian distribution. Otherwise we will not be able to write like this. Now m1 is equal to, m1 is 12.41. Here you can see m1 is 12.41 and m2 is 8.40. So if you substitute that here, m1 is 12.41, m2 is 8.40. So m1 minus m2 modulus is 4.01. So 3 into root of 1.12 square is 1.2544 plus delta square is equal to 4.01. This implies 4.01 by 3 is equal to root of 1.2544 plus delta square. So if you solve this equation, you will get delta approximately equal to 0.73. So the correct option here would be option B. Option B is the correct answer. Now let's go to the next question. This is a question from JEST 2015. Here we have electronic charge equal to E is equal to K eta raised to 1.5, and we are asked to find the error in calculated value of E. Here there is a printing mistake. In the calculated is repeated twice. This is not needed. So what would be the error in the calculated value of E? There is only one in the calculated. These types of questions we see from class 11 or 12. So to do this, let's say we have a quantity Q is equal to x raised to a, y raised to b divided by z raised to c. So if we calculate percentage error, we write like this: delta q by q into 100 is equal to a into delta x by x into 100 plus b into delta y by y into 100 plus C into delta Z by Z into 100. So whatever is the powers here, they will become multiplication, and multiplication will become summation. Okay, so that's how error propagates. So this means that delta E by E into 100 is equal to 1.5 into delta eta by eta into 100. Here we are not considering k because it is clearly mentioned that k is a function of all experimental parameters with negligible error. So there is no appreciable error in k. So we are not writing percentage error in k. So we need to find error in percentage error in E. So delta E by E into 100, this is the percentage error in E. This is equal to 1.5 into percentage error in eta is 0.4 percentage. 0.4 percentage. So you put it here, 1.5 into 0.4 percentage is equal to 0.6 percentage. So the correct answer here is option C. This question here is from JEST 2014. We are told to find the maximum error in the measurement of strain. We are asked to find the maximum error. So there is a formula for maximum error. Maximum error in this quantity, epsilon. Maximum error delta epsilon is equal to del epsilon upon del F into delta F plus del epsilon into del A. You take modulus here into delta A plus del epsilon into delta E modulus delta E, del E into delta E. Now if you calculate del epsilon upon del F, you get del by del F of F divided by AE. So this is equal to 1 by AE. Its modulus will be 1 by AE modulus. Similarly, if you calculate del epsilon upon del A, you will get del by del A of F divided by AE. So this is equal to F by E minus 1 divided by A square. Take modulus. This will be equal to F divided by EA square. And del epsilon upon del E will be equal to F divided by AE square. AE square. Therefore delta epsilon will be equal to 1 by AE modulus into delta F plus F divided by EA square into delta A plus F divided by AE square delta E. Now F is equal to 50 delta F is equal to 0.5 Newton, A is equal to 0.2, delta A is 0.002, E is equal to 210 into 10 raised to 9, delta E is 1 into 10 raised to 9. So if you substitute these values, delta epsilon will be equal to, this will be equal to 2.95 into, approximately this will be equal to 2.95 into 10 raised to minus 11. So the correct option here is option B. Moving on to the next question. This is a question from JEST 2012. So I will first give you an example. If there is a quantity Q, which is equal to x raised to a y raised to b, then you are given the RMS error in x, given RMS error in x, RMS error in y, then RMS error in Q is equal to, this will be equal to A into RMS error in x squared plus B into RMS error in y squared, take root. This will be the RMS error in Q. So here we are asked to find the RMS error in inferred volume of cylinder. So V is equal to, volume of cylinder is given by pi r square h. This implies RMS error in V is equal to under root, the power of R is 2, so 2 into RMS error in R squared plus power of length, the length is height which has a power 1, so 1 into RMS error in length in L, take square of it. So this means RMS error in V is equal to root of 2 into 1% plus square plus 1 into 1% square. So this is equal to root 5%, which is 2.236%. So the closest option here is option A, 1.7%.